Hello guys, welcome back to MedZone African Motives. We are still on our engineering science N3, working on moments from the question paper, which was written in November 2023 exams. So this is our question that we're given on moments. So we shall just quickly rush through the questions so that we shall see how we're supposed to attempt these typical questions. 2.1, we are given to state the law of moments. Right, what is the law of moments? That was our question in that case, and that is 1 mark. So remember that for the law of moments, it's all about the system of forces which must be in an equilibrium, all right? So we can just state it this way, that it states that a system, so you're going to have a system of forces is an equilibrium. All right, is an equilibrium. All right, on which condition if the sum, so we're going to talk about the sum in this case, if the sum of the left hand, so we're going to have the left hand moments, all right, the sum of the left hand moments about the fulcrum, in this case, which is our turning point, all right? Remember, the fulcrum is simply represents the TP, which is our turning point. This is equal to the sum again, the sum of the right hand moments this time. So you're going to have the sum of the right hand moments. All right, so simply talking about clockwise and anti-clockwise moments. That's the case. But it is referred what about the same fulcrum, which is about the same turning point, about the same fulcrum in this case, all right? Which is simply our turning point, like I talked about there before. So it's simply the clockwise moments should be equal to the anti-clockwise moments, right? That is the idea for this is our law of moments. Then not forgetting that the definition is can be written in basic ways, right? You can choose a way of writing your definitions in a way that you understand it, okay? Which is fine. On 2.2, we are given fig 1 shows a light horizontal beam, all right? This is a light horizontal beam, A, B, C, D, and so forth. We've got A, B, C, D, up to E. Of a uniform cross-section loaded as what? As shown. So this is what we have here. Okay, so taking this into consideration, all right, we've got here a point load at the beginning here at point A of 15 kilonewton. Then we have got uniformly distributed UDL here, meaning to say we can just have this as a point load, like I said before, just gonna have this as a point load. 5 kilonewton per meter is affected for 2 meters, all right? So it's gonna be 5 kilonewton times 2 meters, all right? So that we cancel per meter. So 5 kilonewton per meter times 2 meters is gonna give us what? 10. That's 5 kilonewton per meter times 2 meters. So the meter and the meter will cancel. We're going to have 10 kilonewton as a point load. All right. So you're just going to take this as a point load of 10 kilonewton. And this will be separated now between B. If you divide 2 meters by 2, because now the distance is divided into 2. So this will be 1 meter this side. And we know that this will be 1 meter this side. Okay. This side is fine. We move on from B, which is a sub, we've got a support here, B, all right. Then at C, there is a point load of 25 kilonewton. Then at D, we've got a support, all right, facing up, that's a support. And from that point up to the end, there's a UDL, uniformly distributed load. So what are you going to do? Again, put it as a point load like this in between the distance of 6 meters. So that is going to be separated 6 divided by 2, going to have 3 meters. So this will be separated between 3 meters here and also 3 meters on this side, okay? But the total force is going to be 8 kilonewton per meter times what? The distance of 6 meters. So if you multiply 8 times this 6, we are going to obtain what? 48. So this will be 48 kilonewton, all right? So you're going to take it as a 48 taken between 3 meters and 3 meters from what? From point D, and 3 meters from point E. Okay, so that is what we can do on our analyzing when we are just analyzing our diagram. All right, so 2.21, it was to calculate the magnitude of the reactions at the supports, which is the support, it's at B and at D. All right, so let us start by taking moments about B. All right, just gonna choose which one do you want to start with. All right, so I'm just gonna start with B. So I'm just gonna take taking moments about B. All right. So if we are to take our moments about the point B, remember our law does, I mean, the idea does not change. The sum of the clockwise moments in this case should be equal to the sum of the anti-clockwise moments in that case, okay? We have this from our formula sheet, guys. We can just also take it from there. Okay, here. Okay, so that's the sum of the clockwise moment is equal to the sum of the anti-clockwise moments. Okay, so the formula is there. It's just an application of the formula. How do we take our moments? All right, clockwise from B. All right, remember it's about B. About this here, B. This is where we are. We're just gonna close this part where B is like this. All right. So about the point B, if we are to check here, remember the clockwise is moving this way. This is how the clock moves, all right? So you're gonna talk about this. That is the clockwise. And anti-clockwise is the other way around. That will be our anti-clockwise. Okay, so considering the B going to be, okay, let's take these ones which are on the left side of what? Of B. How are they related as they are moving back to B? This is the 10 kilonewton. As it moves back to B like this 10 kilonewton here, as it moves back to B. Which direction is it, this 10 kilonewton, as it moves back to B? This is anti-clockwise. So there we've got an anti-clockwise. Okay? The same thing with the 15 as it moves back to B, that's an anti-clockwise. So all these forces on the left, as they are going back to B, they're in the anti-clockwise. Okay, if we check what is happening on the other end, we've got this 25 moving back to B here. Is take note the direction. This is clockwise. So we've got a clockwise as it goes back to B. And okay, what about D? D is gonna move this way. This is the direction of D. D is gonna take this way. D as it is going to B. Take note. Which direction is that? That is an anti-clockwise. Take note, guys. Take note the way of anti-clockwise. This is the way. We are going this way. And this is the way that from D, we're going to move this way. This way. Which way is this? Anti-clockwise. All right? So meaning to say as D is moving back to this B, is moving in the anti-clockwise, all right? So D is also part of the anti-clockwise, all right? So this is an anti-clockwise, all right? What about the 48 kilonewton, this one? Now, because we now have a 48, this one is going to go this way to B. And which way is this one? This is the clockwise. So it's on the clockwise. Remember, this is our clockwise, these are anti-clockwise in green. Okay, so gathering up this information, let us answer this. As we said, it is going to be the sum of the clockwise moments first. So the clockwise moments, like we say, these are the ones that are in the clockwise. 25 as it goes back to B is 25 times what? 25 times 3. So you're going to have 25 times 3. All right, so that's 25 times 3 plus we still have another clockwise. All right, we started with this one, 25 times 3. We still have another clockwise here of 48. So it's 48 back to B. The distance back to B here is going to be what? This is the distance. So it's going to be 3 plus 4, which is 7, plus 3, which is 10. So that's 48 times 10. So this will be 48 times 10 is equal to the anti-clockwise moments we are done with the clockwise, okay? Isn't it? Yes, all the clockwise. So we're going to the anti-clockwise. So we have got D as it goes. This is anti-clockwise. D as it goes to B. The distance there between B and D is 7 meters. 3 plus 4, that's 7. So that's D times 7. Force times distance. That's D times 7. We still have another anti-clockwise this side here. It's going anti-clockwise, all right? 10 back to B. Here we are going back to B. So the distance between this is 1 meter, all right? This one, remember, it was divided between the 2 meters. So it's going to be 1 meter back to B. So that's 10 times what? 10 times 1. Force times distance, 10 by 1 plus, we still have another one at the end, the 15 kilonewton back to B. The distance there covered is the 2 meters. So we need the distance between these 2 points, which is 2 meters. So it's 15 times 2. It's part of the anti-clockwise, remember? So that's 15 by 2. Okay, so that's it. Combine everything on the left-hand side from your calculator. That was going to give you 555 is equal to D times 7, simply means 7D, plus if we combine these two that are remaining here, we are going to obtain a 40. So that's a 40 there. All right, transpose 40 to the other hand is going to be a negative. So that's 555 minus 40, which is 515, is equal to 7D. Divide by 7 by 7. So that's our D is going to be 515 over 7 as a decimal. That's 73,571 kilonewton. Okay. So that is how we could have obtained the value of the support at what? At D. This is for D. Okay. Let's just put it this way. That is the value for D. Now, so that we can properly have our calculations, we are going to take our moments about another point, which is D, as our support this time. So you're gonna take moments about D this time. All right. So taking moments about D. Taking moments about the point D. All right. So what is gonna happen this time if we are to take our moments about D? The formula, I mean, the idea is not going to change, that the sum of the clockwise moments should be equal to the sum of the anti-clockwise moments, all right? But we have to consider the point D now, all right, from D. All this information that we had was from point what B. All right, so this one is just going to affect us, but I hope guys remember what we had before here, because I'm just going to remove this. Remember here it was 1 meter, 1 meter here. It was 1 meter. This was also 1 meter here. All right. So as I said, this time we are considering from the point D. D is the point that we have here. That is the D, this one. All right. So let's consider the clockwise, or our forces as they are moving to D. All right. Let's take this one. Which direction is this as we are moving to D? This is the clockwise. As we can see, we are maintaining the clockwise. So this one is moving in the clockwise, all right, direction. All right, let's move to this 25. It is moving this way. And what is that? Anti-clockwise, all right? So this is moving back to D in the anti-clockwise. So let me just put the anti-clockwise another one like this. So this is in the anti-clockwise, all right? Then B, as it moves to D, it is moving this way. This is our B. Which direction is this? Clockwise. That is how the clock moves, like this, all right? So B, as it is going back to D, it is in the clockwise. So this one, that's a clockwise, all right? But if you take a consideration of 10, it is the same as this 25. It is moving this way in the anti-clockwise. So 10 is moving in the anti-clockwise, and also 15 is moving in the anti-clockwise back to D. All right, so the only clockwise that we have is this one and this one, these two. All right, so you're gonna add these on the clockwise moments. All right, so we said the first one, let us take the first one from here. 48 back to D here, the distance back to B is going to be what? To D, sorry, back to D, the distance there is what? 3 meters. There's a difference there of 3 meters. So that is going to be 48 times 3. All right, we still have another clockwise moment, which is from the B, considering the B as it moves back to the point D. What is the difference between these 2 points? As we can see here, there is a 7. 3 plus 4, which is 7 meters. So that's C times 7. All right, that's B times 7. B times 7. So this is going to be B times 7. All right, is equal to, we move on to the anti-clockwise. We say the anti-clockwise, we have got this 25 kilonewton. All right, it's anti-clockwise there. All right, so as it moves back to D here, this is where our D is. So it's going to be 25 times what? Times 4. There's a difference there of 4. So that's 25 times 4. 25 times 4 plus, we still have another anti-clockwise here. Another anti-clockwise, which is of the 10 kilonewton back to D. So it's going to be the difference back to D here to 10 kilonewton here. So this is the difference that we want. So there's a difference of 4 plus 3, which is 7, plus this one between these 2 points. So that's 4 plus 3 plus 1, which is 8. So there's a difference of 8 there. So that's 10 times 8 back to D. So 10 times the difference of 8. All right. Then another one, the last one is the 15 kilonewton, is also anti-clockwise. Back to D, the distance there is going to be taken as 4 plus 3, which is 7, plus 2, which is 9. So that's 15 times what? 15 times 9. So this is what you're going to have, 15 times 9. So if taken all of the given forces and their given distances, all right? So what you're just going to do is to combine 48 times 3 is going to give us 144 plus B times 7, which is 7B, is equal to, combine everything on the left-hand side, you are going to obtain 315. So that 7B is equal to transpose 144. That side, you're going to subtract. All right, so this will subtract this side, 144. That's we're going to have 171 divide by 7, both sides, so that we have the exact value of B. That's our B. I was going to give us 24,429. All right, so this is a 429 kilonewton. Okay, so that was the idea of our question there. We've got the value of B, 24,429 kilonewton. All right, so we can just cross-check this to see if we are in the right direction from the sum of upward forces. We know that this we can just prove this from the sum of the upward forces should be equal to the sum of the downward forces. All right, so the upward forces are the ones that are facing up, the ones that are going up. Let us just remove this. All right, the ones that are going up, those are our upward forces. All right, which forces are going up? The ones pointing up, which is the support, the B and the D. So if we add the B and the D, we must obtain the downward forces. All right, so that is B plus D. B, which is 24,429 plus D, and D is 73,571. This should be equal to those ones that are pointing down in this case, which is, we've got 15, 10, 25, 48. So you're going to add all those ones that are pointing down. What are we going to have there? So we said we've got 15. We also have 10. We also have 25 and also 48. All right. So this was going to give us 98 kilonewton, which is also equal to 98 kilonewton on the other hand. All right. So that is just for you to cross-check, because remember, you calculated these differently. So you are supposed to also check if they are giving you the exact values on that consideration. All right. So that was the idea of the question. Then after that, they want us to draw to a suitable scale the shear force diagram. All right. So I'm just gonna need the values of of B and D here. Remember the values of B and D that we calculated. Guys, do not forget your values because I'm gonna remove this. All right, so this is it here. All right. So remember that we were at B, the value of B, we obtained the value of B, it was 24. That was 24,429. This is 429 kilonewton. Then D, it was given as, remember our D, we calculated this, we got 73,571 kilonewton. All right, so this is what we had. So you are going to have a scale which is appropriate, all right, to make sure that these values are there. And all right, so here I'm just going to show you a sketch, guys. I'm not going to have this accurately because, guys, here it's impossible for me to have this accurately. All right, it's actually very, very impossible for me to have this accurate. So I'm just going to show you a sketch. But you are supposed to just choose a certain scale. Okay, let me just show you, or let me just even put this one. I just hope you understand. All right. So maybe let's say you've got something like this. All right, and as we know that this is going to represent the forces that we obtained. All right. Okay. So maybe this is where we're gonna, okay, let's say I'll have our origin here. And as we are going up, we know the positive, going down, it's a negative. And according to your scale, maybe this is 5, 10, or maybe you're using 10, 20. It's up to you. Okay, the scale that you're using, let's say we're gonna 10, representing 10 boxes, all right, according to your scale. It's gonna be 10. Maybe we've got our 20 here, 30 there, 40, and 50, maybe somewhere there. Okay. And the same thing going down, negative 10, negative 20, negative 30, negative 40, negative 50, and so on. All right, the same thing as with the scale. I don't know how we're gonna take, because these are centimeters, and if you measure the wall of this, if you take this is 2 plus 3, which is 5, all right, plus this, which is 9, plus which is 15. So in order for us to get up to 15, we can even use maybe 2, 4, 6. It's up to you guys, all right? It's up to you. So you can even use 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and so on and so on. We said we want 15, isn't it? 10 plus, which is 15. So we are already there. Okay, so now that we have this, let us consider the first part. The first part is that we are at the point 0 here at the origin, or I mean at the starting point, that's at 0. But at the same point, there is what? A point load which is going down. And I said everything that is facing down like this is a negative, all right? All point loads, they are going down, it's a negative, and you represent with a vertical line going down. All right, so you're gonna go down up to negative 15. From 0, gonna go down up to negative 15, which is approximately somewhere there, going down, okay? So you mark your point there, which is at what? At negative 15. Then from there, if we check between these points here, A and B, what is happening between A and B? There is a distributed load of 5 kilonewton per meter. So we are going to subtract, and a distributed load is represented with a diagonal line, like with a slanted line like that. So you're going to subtract 5 affected for how many meters? For 2 meters. Remember, we are at what? We are at negative 15 here. This is at negative 15 kilonewton at this point. So you're going to have negative 15. Then we subtract the 5 kilonewton, which is affected for how many meters? For 2 meters. So meaning to say we're going to end up at negative 25. So this is corresponding after how many meters here on our diagram? After 2 meters at B. So after, just according to your scale, maybe this is where you have your 2. So it's 2 versus negative 25, which might be somewhere here. Guys, this, as for me here, I'm just going to have a sketch. I'm not going to have something accurate here. It's impossible for me to have that accurately here, but I'm going to try to do that next time as we move on. So just going to join at negative 25. Remember, this is at what? Negative. Okay, this is too far. All right, something like this. All right. So as you can see, that's for a distributed load. You're going to have a slanted line. Even if you do not know this, by just joining, you can see what is happening. All right. So this is at what? At negative 25. Remember, we are at negative 25 kilonewton here. Then what is happening after this at 2? We've got B, which is what? A support. So a support is always going up. It's a positive and it goes vertically up. So you're going to add 24,429 in this case, all right, to this value that we are having, because remember, we are at negative 25. So at negative 25, if we add B, which is 24,429, we are going to end up at negative 0,571. That is where we are going to end at. And remember, we are going up, and this is approximately just before, this is just before 0 here. So you're gonna go straight up, approximately the somewhere here, right? Somewhere there, we're gonna have negative what? Negative 0,571. Negative 0,571. All right, negative 0,571. Okay, let's see what is happening there. At this point B, if you see from B to C, there's nothing. There's just a distance of 3 meters. You're just gonna move 3, meaning to say we'll be around somewhere 5 there. So you're just gonna move straight. There's nothing that is happening there. We do not have anything there. We do not have any distributed load. We do not have anything at all. So just maintain that for 3 meters. So it's gonna be approximately around 5 there. All right, somewhere there, around 5. So we are still at the same value at negative 0,571. We are still at what? At negative 0,571. Okay. Then what is happening there? After this distance, we are now at C, where there's a 25 kilonewton, which is, remember, it is going down, so it's a negative. So you're going to subtract 25. Where we are at negative 0,57, at this point here, at negative 0,571, you subtract 25 because you are going down. So it's going to be negative 25,571. So it is going down. Remember, this is a vertical line. So you're going to draw a vertical line up to that negative 25 comma that we have, which is just approximately just below this, because this was at negative 25, just approximately just before that point. All right, just slightly before that point. All right, slightly after, like this, just somewhere. Okay, that will be at negative 25,571. Okay, 571 kilonewton. Okay, let's check what is happening from that point load that is going down. We now move a distance. There's nothing for 4 meters, all right, up to D. So here's just a vertical line where we are. Okay, so we're gonna have something like this. Okay, sorry for that, guys. Just hope it's gonna be clear here. Okay, just a vertical line, all right? So it's just gonna have a vertical line straight, and it's for how many meters there? 4 meters. So we are now approximately somewhere around 6, 7, around 7 there, 4 meters. Okay, guys. So this you just take according to your scale, all right? So it just approximately is there, 4 meters. We are still maintaining the same what? The same value, because there is nothing there. So we are still at negative 25,571. But what is going to happen is that after covering this distance of 4 meters, we're now there at point what? At point D. We are now at point D. All right. We are now at point what? At point D. So at point D, what do we have? It's a support, which is 73, and I said the support you add, and it's a vertical line that you're drawing. So you're going to add 73.571 at a value that we are now. Remember where we are at negative 25.571. At negative 25.571, we add the value of D, which is 73.571. You're going to see that you end up at 48 then. On top at 48, and 48 is above there on top. So meaning to say, this will be a vertical line up to 48, maybe 48 just about, approximately below what? Approximately below 50. That's where you're going to approximate our 48, somewhere there. It's a vertical line up, straight up. All right, just somewhere there. Going to approximate there at what? At 48 kilonewton. Okay, the support is going up. Then from there, what is going to happen? If we check the last part, it's a distributed load, distributed up to the end. 80 kilonewton per meter for how many meters? For 6 meters. So you're going to subtract this from the last one that we are. Remember, I said a distributed load. We're just going to multiply. It's 80 kilonewton meter times the 6 meters. So that will be at 0. So meaning to say, for the remaining distance that we have up to the last point after the last distance at 15, it's going to be at 0. So the last part that we have is going to be joined direct to what? To 0 there. That's the last point that we have. It's going back to 0 after subtracting the distributor. So as you can see, by just mere looking, if you are to join, it's going to be what? It's going to be a slanted line. So even if you do not know how to represent your uniformly distributed load, it just shows it on its own on the diagram. That one, do not worry. By just joining, you see, okay, this is what I'm having, as you can see. All right. So that is what your diagram is supposed to look like. By just joining, you see that, okay, this is what? A UDL that we have. Same as this part. You don't need to know the concept. Yes, it's fine that you know the concept, but in case that you've forgotten what is happening, the diagram on its own, as you are drawing it, it gives you accurately what you are supposed to have at the end. So, guys, that is what you're supposed to have. We just have to revise more questions, like I said, of this typical nature, so that you'll be able to understand your questions and how to answer these typical questions. But that's it, guys, for now, till we meet again.